Hola chamas y chamos, welcome back to Álvaro Dev Labs. Today we're gonna continue our journey using TresJS, which is a library that I created for Vue developers to be able to build 3D experience based on WebGL and 3 using Vue components. If you want to learn more about the basics, I have several videos in this list so you can continue learning. Today we are gonna touch a really interesting topic, which is cameras. Cameras are one of the core concepts of 3D scenes, and we are going to take a look of the different cameras that are available on TresJS as well as 3JS and how to use them. We're going to see the perspective camera, which is the one that you see right now, where the object has perspective, and then we are also going to see the orthographic camera, which looks like pretty funny. So we are gonna take a look of the different parameters and configurations that you can use in each one of them. Let's go. This is how a normal camera from your phone or the ones that are used in cinema works. Is that you have an object nearby the camera and it's gonna appear larger than one that is far from the camera because the distance from this axis that covers the camera is bigger, so that's why you see it a little bit smaller. That exactly is a perspective camera. So looking for a similarity here, the one that we have in 3GS, okay, on 3GS, it's a perspective camera that has a width and a height, okay? So this axis form a volume where you have the aspect ratio, which is the width and the height. And then you have a field that is called the field of view, which is FOV. That is how narrow the camera is, how narrow the axes are. So if you have a smaller field of view, for example, you're gonna have a narrower view here. Other parameters that are important in the perspective camera is the near and far values. So these parameters will tell you where the camera can record or see objects. So you're gonna define how near to the camera you can see, okay? And how far the camera will take a look. So any object between both is gonna be visible in your camera. But if you set an object really far for the far value, it's not gonna be visible. This is often used in video games to avoid loading objects that are too far away and it cannot be visible by the camera. Okay, so let's create a project with the starter of TresJS. It's available on the description below, the repository, but you can initialize the project by using npx digit and then just look for TresJS started, and here let's put cameras TresJS, okay? So if you click enter, it's gonna install everything, it's gonna clone it, and then we can do code cameras TresJS. Now that we are inside, let's just quickly install everything. So we're gonna use ni, which is npm install or whatever you have in your packet JSON. In this case, I'm using pnpm. And also I'm seeing that these are quite outdated. Okay, so I'm gonna update it to the latest beta. In the meantime, so it's gonna be the core. In the point of this tutorial, we're using the beta.13 and for cientos. I think we are not gonna need cientos today because we are not gonna use the orbit controls. So cool, let's use nrdev. Okay, so I opened this Vite server. I'm just gonna remove here and let's open the experience, which is the Vue component that hosts this. I have a default GLTF component here for with a model, but let's just remove everything and start from scratch, okay? So let's click save. And then we no longer have anything. Okay, so now let's try to add something inside of the scene. So we're gonna use TresMesh. And then inside of it, we're gonna use TresBox geometry. Okay, and we're gonna use not a standard material, but a normal material, and just remove the color real quick. To add a perspective camera, we just need to here use Tres and then perspective camera. Okay, so if we add it without any parameter here, you're gonna see that it's working, and that's because TresJS, when it doesn't detect the arguments and the initial position, it does it for you. So you don't have that issue that you're in the center of the scene and you cannot see anything. Okay, so we got you covered on that. But you probably want to pass some arguments in order to change the parameters that we were seeing in these slides. So we have here the field of view, okay, the aspect ratio, which is auto-calculated by TresJS, and then you have the near and far, okay? So what we're gonna do is here, we're gonna pass some arguments. As you've seen in the previous tutorials, arguments is the way that you can pass the initial constructor. So whenever you're doing this with plain tree, you're gonna do camera equal new perspective camera, and then you're gonna pass some parameters here, which is the field of view, this one here, the field of view, the aspect ratio, and the far and the near. But we can do exactly this by passing the arguments here. So the arguments are gonna be 75 for the field of view. It's not the normal field of view that you will have in most of the cameras, but for beginning in 3D is really good because you can see everything. Okay, you can see more of the scene. Then the aspect ratio is, we can put 1 because it's gonna be auto-calculated by TresJS and the window or the container. And then the near and far. So how far we want, like 1000, okay? So you can see that it cannot change it, the field of view, right? I can put something like 45 here, and you can see that now it looks closer and probably the perspective is different. So this is how you will tweak it, okay? If I put 10 here, for example, and refresh, nothing happens because we have a lot of space, but let's say I want half of the box, right? You can see that it's no longer visible. If I put 75 here and refresh, it's still not visible. If I put 1, still not visible. So with this one, you can tweak where is the object. If I put 5, you can already see that it's cutting the cube. So it's showing the pixels that are between the near and the far. Now let's talk about the transformations. So I'm going to pass this to 1K again, so we can see the whole screen. I'm probably also going to add a grid view or a grid component. So the grid helper, and let's see, probably we need to pass the arguments, which is the size, okay? Ooh, I put something wrong. The grid helper, no, Tres grid helper. Okay, so now we can see that we have this grid right here. I don't know if it's visible with the color of the background, but maybe we can change the color of the background actually. This value, that is the one that I had before. Okay, now it's way better, right? You can see that now the cube is in the center of the scene, but it's like inside of the grid helper or the other way around, right? So if we want to change the position, we can use position and then pass a vector or an array with the coordinates in the different axes, right? So we want it to be up to the grid. So we're passing 1 and something wrong, maybe. Because we're passing it to the camera. I'm sorry. It needs to be to the cube itself. That's one thing. Okay, because the cube is 1 by 1 by 1, you probably need to use this 0.5, and it's gonna be completely centered. That's better. But you can see that you can also change the position of the perspective camera. So if I use position here and probably try to make it far, now you can see that the camera is pointing on front of the scene. Let's take it back. Let's do this. Okay, you see that this is the blue one. And then if I add it again, and this is the set value, which is this axis right here. Now it's gonna be in front of it, but real behind. So with this, you can change the position of the camera. But what about, like now it seems odd because it's way up, right? And you can see that this is the grid helper. So how we can set, I don't know, like let's put 3 here and see what happens. Now you cannot see it anymore, okay? Because it's probably too up and not close enough. So there is a property or a method that you can use, which is look at. And the way TresJS works is that you also can pass, it will detect if the property is a function or a method in the instance, and it's gonna pass this as an argument. So in this case, we're telling it, please look at the center of the scene or where the cube is. And now it's visible again. So it's in this position, but instead of looking straight away, it's gonna look to the center of the scene. The good thing is that you can also play with those parameters. So I'm gonna show you here the example where I configured this TweakPane, and here we can change the field of view, and you can see that the bigger the field of view, the smaller it looks because it's too wide, like the lenses got too wide. When the narrower you put the lenses, the closer it's gonna look. Also, we can play with the near and far. So if I increase the near, you can see that it starts cutting the object because it's not gonna render the vertices and the pixels that are there. Same for the close. So maybe we can even do something like this between the two of them. And then you only cover this part of the scene. So this is how you can tweak a perspective camera. Let's now talk about the orthographic camera. So perspective camera is the counterpart for a physical or like a real camera, but the orthographic one is actually doesn't have a physical counterpart. It's a projection. So orthographic projection is when you try to represent a 3D a scene or object into a 2D space. And I'm not gonna go cover because it's a lot of math, matrices and so on, but you can see it here in the orthographic projection. I'm gonna explain it with the examples that we had before. So you remember the cats, right? In the perspective camera, the objects that are near there to the camera are gonna look bigger than the ones that are far from it. In the orthographic camera, it doesn't happen that way because the axis doesn't have a field of view. So all the objects, no matter how far or how near, are gonna be exactly the same size because there is no difference with the distance of the objects that modifies the size of it. Okay, so the orthographic works a little bit different from the perspective camera because it doesn't have a field of view, as I say, or aspect ratio. What it has is the near, the far, okay? But it's represented with where is the left, where is the top, the right, and the bottom. You probably have seen this camera in a lot of video games that are isometric, such as this one right here, where all the, no matter how far the objects are, they look kind of the same proportions. So let's change the perspective camera that we have here for an orthographic one. So to do that, we are going to add the orthographic camera. And let's put it without any arguments to see what happened. Okay, and if we refresh, we already see that the cube looks in a different proportion, right? Because let me put back the other one so you can see it really quick. Here you can see that we have this sense of depth where the axes are like they look at the different size, right? So this right here looks a little bit larger than the ones in the vertical axis, right? Even if the cube is 1 by 1 by 1. But by using the orthographic camera, now you can see that this one and this one, the vertical and the horizontal axis, they look exactly the same size. And that's the effect that the orthographic camera gives to you. So for arguments, as I explained before, for the perspective camera, those are the arguments that are passed to the instance. So in this case, we have the left, top, right, bottom, if I remember correctly. So I don't know what parameters normally are used because I don't use this camera a lot. So left minus 10, 10, 10, 10. Okay, so we can do from the center, it makes sense. So minus 10, it was 10 and 10. And then how near and how far. These are exactly the same as the other one, right? So I did something wrong because now I cannot see anything. So probably is left, right. Maybe it's left, right. One way that we can actually see which ones it is let's create one using the orthographic here camera. And it's left, right, top, bottom. Okay. So it's gonna be 10 left, right, top, bottom. So I suppose the bottom is the negative one. Yeah, okay, now it's working. So you can see that we see the object quite far. So if we want to see it a little bit closer, I guess we have to reduce the left, top, right, and bottom. Okay, cool. This one also, I think it has look at, I don't remember correctly. So let's try to change some parameters. Let's see that we want to go a little bit up. So I will put 10. And then you can see that it actually deformed a little bit because we are increasing the distance here. You see? So I put 10 and this is the distance here. If I select this one, the left, right? This distance here will increase. Like this, okay? So this is how you will move around with it, but it's a little bit uncomfortable. So let's go to this example that I have here and we can tweak a little bit the values. So this, as I was saying, is changing the distance in the left. We can do the same for the right. And we can select how far or how near, similar to the previous one. So these two works exactly the same. Let me try something that I haven't tried with the orthographic is passing the look at. So look at 0, 0, 0 and see what happens. So it didn't do anything at all. If I say, I don't know, 8 here. Oh, well, it does. Okay, so if I put bigger value in the y-axis, it is changing it. But it looks like it doesn't have the top part. What happens if I put like -4 here? Okay, that's cool. So this is the orthographic one. I have used it like in some scenes where I wanted to give this isometric look, but I'm not often use it, to be honest. So the last thing that I want to show you is that you can actually animate the camera. So you can achieve those cinematic effects like going away from an object and things like that. So to do that, we are going to To do that, we need to access the reference from the perspective camera, because what happens in normally animations in 3GS is that you need to do them in the request animation frame on the loop. So if we try to modify, for example, we have the position right here, and it's a variable that is position, okay, or camera position. And we go here and say camera position, and this is reactive, for example, something like that. And we modify this every frame per second. This is gonna blow the performance. So what we need to do is remove this here and use the template refs. So we're gonna create a camera ref, okay? And this is gonna be a shallow ref of perspective camera. And we need to pass it as a reference here. Okay, so this is gonna give us the value of the instance. So we can watch over it of the camera ref, and if there is a camera, I'm using GSAP. GSAP is a library that is really good for more advanced animations, especially if you want to use easing. Okay, give this easing. No, I'm joking. It makes animations really easy, okay? And it works really well with TresJS. So I just installed it and imported it here, okay? And the way you can use it is that we are gonna change whenever the camera is available, we're gonna change the position. We are gonna add a delay of 1 second to start the animation. Then duration of the animation is gonna be like 2. And right now the position of the camera is around 3 in each axis, okay? So we are going to go a little bit farther from the object itself. And we are gonna use power 3 out easing. So if I save this, you now see that it went far. I'm gonna refresh it. And that's how you can animate the camera. You could put, for example, another value here in the, let's put in the X here, so like 20. And you see that it goes far from here, but let's see something really interesting here that you can achieve. And is that you can listen to several events. So you have on complete, on repeat, etc. And let's put one that is on update. So every time the it's updating the animation, we are gonna ask the camera to look at the center of the scene. So now you can see that the effect is different. It's still looking all the time to the center of the scene, but it's looking a little bit more in the right. So if we put even bigger here, you can see that now it looks completely in the right, but it went too far. And that's how you can animate your camera. And this, my friends, is everything for today's video. I hope you enjoyed it and you learned something new about perspective and orthographic camera. If you want to follow a lot of the different tutorials that we have in the channel, you can check in the description below on the list of TresJS. I have a really big announcement to make. In the 12th of May, I'm going to be talking at Vue.js Live London, along with a roster of amazing speakers, and I'm going to be talking about TresJS there. As well, I'm going to give a workshop on the day, I think it's the 16th of May, about TresJS, so you can go from scratch without any knowledge of 3D to having actually something in TresJS. As always, subscribe, drop a like, and all your questions and comments in the description below. I'm also gonna add the link for the playground so you can play with the orthographic and perspective scene that I was using for this video. Thank you everyone, and enjoy doing 3D with Vue.